Welcome back to Introduction to Computational Chemistry at Valparaiso University. In this short session, I'd like to talk more about molecular energies, the results of the calculations that you do with Gauss view and Gaussian. And I'll briefly talk about the units of these energies and what they mean and how you can compare energies of certain kinds of molecules. First, what are the units? And programs like Gaussian report all energies calculated in units of Hartrees, and those are sometimes referred to as atomic units and abbreviated AU. Hartrees can be converted into more common units that we measure in laboratory experiments using the following conversion factor. 1 Hartree is 627.51 kilocalories per mole. If we multiply that by the conversion factor between calories and joules, we get 2,625.5 kilojoules per mole. And if in turn we multiply that by the appropriate conversion factor, we can convert that into EV or electron volts, 27.211 electron volts. So when you use energies calculated from a program like Gaussian and maybe copy them and paste them into a spreadsheet, you might want to take the values in Hartrees and convert those into one of these units, depending on whichever one you're more familiar with. Now, what do the molecular energies that Gaussian calculates mean? And the answer to this question depends on whether you're using a semi-empirical method or whether you're using a more rigorous quantum mechanical method. In a semi-empirical method, and one that is often used in Gaussian is called AM1, the energy that's reported is actually a positive value. And because semi-empirical methods rely on the use of some approximations and even sometimes experimental information that gets incorporated into the method, that energy is designed to give you an estimate of the heat of formation of that molecule. And so it's still in units of Hartrees, and probably then you would want to convert that into kilocalories per mole. But that's what that energy means, and that's why it has a positive sign. Now, in formal quantum mechanical methods, which actually find the energy by rigorously solving the Schrödinger equation, the energy is actually, it has the meaning that the absolute value of the energy is the total energy that would be needed to take that molecule and remove all the electrons and all the nuclei to infinite distance away from each other. The reason that the energy values are negative when you do a calculation using a quantum mechanical method is that an energy value equal to 0 would represent all of the charges removed to infinite distance from one another. And so if your energy for a particular molecule, let's just say it's negative 100, what that means is it would cost you 100 units of energy in order to remove all of the electrons and nuclei away from each other to reach the value 0. So don't be confused, don't be worried if you get negative energies from quantum mechanical methods. That's exactly what you're supposed to get. And finally, what about the differences in energy between different molecules? It turns out that we really only can directly compare those energies for two different molecules if those two molecules have the same chemical formula, which means they have the same number of each kind of atom. And these include familiar cases like conformers or isomers. And so as a result of this, we can compare two energies for, let's say, two isomers of the same substance, and we can ask which one's more stable. For example, propan-1-ol or propan-2-ol, two different isomers of propanol. We could look at the two energies associated with those two calculations, and whichever one is the lower energy, well, that means that that would be more stable. But we can't compare energies of two substances that don't have the same chemical formula. In other words, it doesn't really make sense to ask which is more stable, ethanol or propanol, because which is more stable, you have to have a common reference point. More stable compared to what? And so we can't just compare two energies calculated for molecules that don't have the same number of atoms of the same type. I hope this is helpful as you venture on in interpreting the results of calculations that you find with Gaussian.